in the way that we'll find analogies between linear motion description and rotational motion description. So again, for linear motion, when we describe motion of the particle, for example, particle mass m, it was given initial coordinate, initial velocity, could be acceleration given, and we can say where is that particle after some time t. What happens to that particle? We don't go into the details what causes that particular motion. So formulas which we wrote, for example, position of the particle after time t at 0 plus v0 t plus at squared over 2, velocity after time t, for example, v0 plus at, and other formulas. We can write some other formulas. Those formulas for kinematics of linear motion. Now, if you have rotational motion, so that is linear motion. For rotational motion, as we spoke yesterday, we described kinematics of rotational motion given such quantities like angle of rotation, or angle at which a particle was rotated from a certain initial line, angular velocity, and acceleration, epsilon, or alpha. We use alpha, so let's use alpha. So those would be analogs of linear physical quantities describing linear motion. So looking by formulas for kinematics, so that is of linear motion. We can write formulas for kinematics of rotational motion. For example, we can write that final angle at which object rotated after some t would be initial angular position of the particle plus omega 0 t plus alpha t squared divided over 2. For omega would be omega 0 plus alpha t and so forth. So that is kinematics. We don't address what causes that particular motion. If you ask questions, the reason for that particular motion of particles, also in the same way, like for linear motion, we need to ask what forces are acting on the particle. So here we need to find analog. So we will ask ourselves about torques, so-called torques. We spoke in previous class about analog of mass. So analog of mass would be, I can write here because it's more important for dynamics of motion. So analog of mass would be a moment of inertia. That quantity, or rotational inertia, sometimes it is called. So for one single particle, it would be mr squared if particle rotates about certain axis, distance r from axis of rotation. So moment of inertia of that particle would be computed mr squared. If it is a certain solid object, so it would be a certain expression. To find that expression, we would need to do integration. And there were some examples of such problems to find moment of inertia of object symmetrical though, which rotates about certain axis. Moment of inertia depends on location of that axis. So it means that moment of inertia of cylinder relative to axis which goes through the axis of symmetry of that cylinder would be different if we take axis of rotation touching cylinder or any other position. So it would be a different quantity. So moment of inertia depends on mass, but also it depends on how that mass is spread around axis of rotation. It would be determined by that. So as was said, in dynamics of rotational motion, important quantity would be torques. So let's discuss a little bit in more details torques. And to do that, we can probably let me pull some pictures here.